This map from Geoscience Australia shows the sedimentary basins in New South Wales that contain coal deposits. You can see the Clarence Moreton Basin here in the northeast of the state, and you can see it extends up into Queensland. The colours on the map represent the ages of the basins, with the darker colours being older and the lighter colours and hatching younger, and in some places they overlap. The sediments of the Clarence Moreton Basin were deposited from 145 to 200 million years ago. This map shows the four main groundwater source types within and overlying the Clarence Moreton Basin. These units are based on the underlying geology and hydrogeology and are used by the New South Wales Office of Water in their management of groundwater extraction and sharing in this area. The green represents the porous rocks of the Clarence Moreton Basin. Porous rocks are sedimentary rocks such as sandstone, shales, siltstones, claystones and coal. These porous rocks form deep regional groundwater systems and are where the coal seams are located. Much of this water source is saline and not used for water supply, with the exception of some minor supplies from shallow areas where the Kangaroo Creek sandstone outcrops. The basalt caps in purple overlie the porous rocks and are relatively shallow, less than 150 metres. Of note is the Alstonville basalt water source, which is an important and highly used groundwater resource within this area. The yellow represents the shallow alluvial deposits in the area. The main deposits are associated with the Richmond and Clarence rivers and their tributaries. And in orange are the relatively isolated and very shallow coastal sand deposits, which are mainly used for stock and domestic and town water supplies in coastal areas. The groundwater volumes discussed on this map are in a unit called gigalitres. A gigalitre is equal to 1,000 megalitres or 1 billion litres. To put this into perspective, 1 gigalitre would fill 400 Olympic swimming pools. Across all the groundwater sources within and overlying the Clarence Moreton Basin, there are approximately 28 gigalitres of groundwater rights. This map shows volume of groundwater rights in different groundwater system types, and the pie charts are relatively sized based on the volume of groundwater rights that exist. The colour scheme in the pie charts represents the purpose for which the rights are used. Navy blue represents irrigation, green is stock and domestic, orange is town water supply, and brown represents industrial and mining. The pie chart here represents the groundwater rights in the fractured rocks, or the basalts. The dominant purpose by volume, approximately 50%, is irrigation. Stock and domestic rights are also significant, about 40% by volume, with the remainder for town water supply and industrial purposes. It is worth noting that of the 16 gigalitres of rights in the basalt areas, in purple, 10 gigalitres are within the Alstonville basalts, which is the hatched area. There are about 6 gigalitres of rights issued in the alluvial groundwater sources of the Clarence Moreton Basin, their dominant purpose being for irrigation, approximately 80%. A further 4.5 gigalitres of rights are issued in the porous rocks of the Clarence Moreton Basin, fairly evenly distributed between irrigation and domestic and stock purposes. The black line here represents the location of the cross-section we will see in the next slide, running from Drake in the west to Evans Head in the east. We can take the previous map view and represent it as a stylised cross-section of the Clarence Moreton Basin, showing the groundwater units vertically. The basin is vertically exaggerated, with the actual dimension being approximately 4 kilometres deep and 100 kilometres wide. One key thing to note here is the depth. The basin is over 4 kilometres thick. You can see we have indicated locations of the overlying alluvium, basalt and coastal sands. These represent the main beneficial groundwater systems, but are so thin that if we plotted them on this map to scale, you would not distinguish the line. The shallowness of the main groundwater systems is an important point. Water supply for extractive uses are in the top 50 metres in most areas and down to 150 metres in some deeper basalt areas. This context is important to consider when we compare it to the 4,000 metres of underlying Clarence Moreton Basin where the coal seams are. The Walloon coal measures here have been the main target coal seam for exploration by Metgasco. More recently, gas in the tight sands at the base of the Gatton Sandstone and the Ripley Sandstones have been of interest for exploration. These units are over 2,000 metres below the surface, and there is very little groundwater in these formations, and certainly less groundwater than in the Walloon coals. There are also two pie charts representing use, with the top pie chart colours relative to purpose and the bottom one relating to volume distribution across the different water sources. In the bottom pie chart, we can see groundwater rights by volume dominating in the fractured rocks in purple. The groundwater rights within the porous rocks represent approximately 10% of the total groundwater rights in the area, and water supplies are generally taken from the upper weathered sections and most likely from areas where the Kangaroo Creek sandstone outcrops. The water sharing plan for this area has not yet commenced, but the New South Wales Office of Water have provided indicative numbers on the groundwater rights available in these systems. This slide shows the groundwater rights currently within the Clarence Moreton Basin in blue. It also shows the approximate long-term average annual extraction limit to the top of the grey. This grey area represents unassigned groundwater within the porous rocks, fractured basalts and sands. These limits are volumes that will be managed to in the water sharing plan, and entitlements will be made available up to that limit. The graph also shows an upper extraction limit for the porous rocks and fractured basalts, which is up to the top of the white. And this represents the maximum potential volume that the long-term average annual extraction limit could be increased to in the future. These values remain subject to change as part of the finalisation of the water sharing plans in this area. There are no additional water entitlements available within the alluvial systems. The limit for coastal sands has been estimated from previously published recharge and estimates of likely sustainable extraction limits. The estimated average annual volume of groundwater taken by Metgasco from the Clarence Moreton Basin is 0.2 gigalitres, and this was published in a Klon-Krippenberger report in 2010, and it's based on a field of 42 gas bores. This volume represents, as a percentage of the Clarence Moreton Basin porous rock groundwater source, 0.07% of the upper extraction limit, 0.7% of the long-term average annual extraction limit, and 4% of the current groundwater rights. The water will be taken from the porous rock sediments. As we can see, there is unassigned water in these rocks. Just one more point should be made here. Coal seam gas companies will need licences to take water under the New South Wales water legislation and in accordance with the Aquifer Interference Policy. Licences are currently still being granted within the Clarence Moreton Basin, as this area is managed under the Water Act 1912. Once the water sharing plan commences, groundwater entitlements can then be applied for under a controlled allocation tender process. If monitoring and modelling prove that coal seam gas activities do impact on other groundwater systems, licences will need to be acquired to offset that volumetric impact. In fully allocated systems, such as the alluvial systems, this will mean market purchase of rights from existing holders. Note that the current groundwater rights are coming from the top 100 metres, and the volume taken during coal seam gas production will be from several hundred metres and up to 2,000 metres below the surface. Upland springs are common in this area, and there has been concerns raised about their protection. There was a study undertaken by New South Wales Office of Water hydrogeologist Richard Green and Commonwealth hydrogeologist Ross Brodie and others on typical flow systems of springs in this area. This section here is representative of the top 100 to 150 metres of the geology in the area. Note the Clarence Moreton Basin porous rocks are shown in the dashed area, and the coal seam gas operators are hundreds to thousands of metres below this top area. This cross-section has been taken directly from their report and shows that upland springs have local flow paths and are rainfall fed. You can see the flow paths of springs in the area and that they pop out at the surface in areas where there is a change in geology or the break of slope on hillsides. This is typical of springs in upland areas and shows that they will not be impacted by extraction of groundwater from the deep systems below. However, it should be noted that for project approval, the assessment of all groundwater-dependent ecosystems, including springs, will need to be undertaken, and that the companies will need to demonstrate that their activities will not impact on them. This map shows the location of the groundwater monitoring bores across the water sources in this area. The pink and red dots represent the government monitoring bores, and the blue dots are Metgasco monitoring bores. There are over 102 sites with approximately 121 monitoring bores within water sources that overlie the Clarence Moreton Basin. There is a logical focus on monitoring groundwater sources that are most heavily used, and these, as you saw in previous slides, are the basalts and the alluvial systems. This higher demand is due to the better yields and fresher water quality in comparison to other groundwater sources in the area. However, when compared to the inland alluvial groundwater systems of New South Wales, the demand for groundwater resources from the Clarence Moreton Basin is relatively low. As a result, there has not been a major focus on long-term groundwater monitoring in this area. However, monitoring does occur, mainly on a project basis, and I will show you some of this data now. This slide shows groundwater levels, or a hydrograph, for a government monitoring bore in the Alstonville basalt. The rainfall trend line, or cumulative deviation rainfall, is in purple and provides the climatic context for considering trends in groundwater levels. You can see the period of record is approximately 18 years, and the shallow bore at this site is in blue, with the deeper bore in red. The groundwater levels are relatively stable at this site. This slide shows hydrographs for 2 government monitoring bores in the alluvium in the Clarence Moreton Basin. The period of record is approximately 10 years, and you can see that levels again are quite stable, but you can see some response following rainfall. Please note the vertical scale on this graph is over 6 metres, whereas the previous graph was over 60 metres. This slide shows some groundwater monitoring from Metgasco in the alluvium over a period of about 16 months. This chart comes from the Klon-Krippenberger report prepared in 2010, and it shows actual daily rainfall and water levels in the alluvial aquifer over a very short time period. The Richmond Valley Council undertakes independent groundwater monitoring of local landholder stock and domestic bores. This program is funded by Metgasco and is managed and undertaken by Council, with samples sent to an independent lab for analysis. This slide shows the location of landholder bores that are participating in the study. The study will provide water quality baseline information for landholder bores with which to measure change.